In this video, we're going to take a look at a couple of applications of composite functions. In this first example, the volume of a cylinder that has a height equal to its radius is given by this equation. Now, when we're talking about composition, it's important to understand that this is a volume equation in terms of radius, or volume as a function of radius. Okay, so in the first question, we're now going to take, it says, express the volume as a function of diameter instead. So that means we need to consider an expression for the radius in terms of the diameter, so then we can do the composition of the two functions. So just knowing what we know in measurement, we know that 2 times a radius equals the diameter. So in other words, radius equals diameter divided by 2. So that really means that therefore the radius as a function of diameter, so written in function notation, equals diameter divided by 2. So in this question A, where we are looking for the volume as a function of diameter, we're really looking for V at R at D. Okay, so hopefully that makes sense to you. Go ahead and see if you can find that composite function. Okay, so that's volume at D divided by 2, which means it's pi. And then we have R cubed, which is D divided by 2 cubed. And so then when we go ahead and simplify that, we get pi D3 over 8. Okay, so volume as a function of diameter. So using that expression, of course, we could solve the next two questions. So the first one says, determine the volume for a cylinder with diameter 5 centimeters. So that's me asking for V at R at 5. And we know that we can just sub 5 into the expression from above. Okay, in terms of simplifying that exact, it would be 125 pi over 8. Okay, if we want an approximate answer, we can punch that into our calculator and get 49.1 units for volume are centimeters cubed. Okay, now you read this question and see if you could figure out what to do. It says determine the diameter of a cylinder with a volume of 416.735 meters cubed. So if you can, pause the video and make sure you got that one. Okay, so hopefully you figured out to put the 416 in for the volume, and then we're just going to solve for the diameter, and you should get approximately 10.2 meters. Okay, let's try another one. In a laboratory culture, the number of bacteria N in thousands at temperature D in degrees Celsius is given by this function, ND equals, okay, and the temperature D at a time T in hours is given by this function or equation. So the first question asks us to say what N at D at T, what that composite function represents, and let's go ahead and find it as well. So I'd like you to pause the video and take a guess and see if you can figure that out on your own. So just in terms of space, I'm going to find N at D at T over here. And I'm going to talk about what it means over here. So N at D at T means, so it's going to be the number of bacteria in thousands, right? As a function of time. In hours. Okay, and that will help us out with our units later as well. Okay, so let's go ahead and find N of D at T. Okay, there's D at T subbed in, and now I'm going to go ahead and plug that in. Okay, and let's make sure that we can simplify that down as far as it can go as well, because that certainly makes evaluating a little bit easier. So you go ahead and do that. Okay, and there we have it, nice and simplified. So now I can easily ask you the question, how many bacteria are in the culture after 4 hours? So go ahead and find N at D at 4. And after 10 hours, you can go ahead and find N at D at 10. Okay, and of course you could do this in steps. You could have just found D at 4 and then plugged it into N at D. But finding the composite function always makes it a little bit easier. So go ahead and find those and interpret your results. Okay, so this first one here, of course, means in thousands. So 13,100 bacteria at 4 hours. And this one here on the right means 16,400 bacteria at 10 hours. Okay, and did just want to show you quickly what I meant before when I said that you could do it in steps. So I'll just show you quickly for N at D at 4. Okay, so what we could do is first find D at 4. So if I plug 4 hours into this expression, I get 12. So I can then find N at 12. And so then I'm going to plug 12 in this expression right here. And so that would give me negative 90 over 12 plus 1 plus 20. And you can double check that that would still give you 13.1. Okay, so it doesn't matter which way you do it. I just think it's easy right away to go and find the composite function. Okay, you'll practice some of these on the next page.